Now this is quite a subtle question, the Waves homework booklet question 34. You've got to use a nice little technique. We've got the interference maximum produced by a double source are observed at a distance of 1 metre from the sources. In which one of the following cases are the maximum closest together? Now you could go through and calculate W for each case, simply putting in the 1 metre each time, but we can be a little bit more subtle than that. If we start with W is lambda d upon S, whatever that distance d was, now it turns out it had been 1, so we could have just left it at that, but whatever that value is, because that's fixed, it gives us that W is proportional to lambda upon S. So if I just calculate lambda upon S in each case, it'll get us to the value I want. Now, in A, that turns out to be 700 times 10 to the minus 9 divided by 4 times 10 to the minus 3, 1.75 times 10 to the minus 6. So that's something times 10 to the minus 6. In part B, it's 20 over 50. Cass not even bothered to work that out. There's no way that 20 over 50 is going to be smaller than 175 times 10 to the minus 6. C is 450 times 10 to the minus 9 over 2 times 10 to the minus 3 is 225 times 10 to the minus 6. So we're looking at 10 to the minus 6, worth doing the sum, but no, it's not going to be smaller than the 175 times 10 to the minus 6. And then finally, 10 times 10 to the minus 3 over 200 times 10 to the minus 3 for D. Again, not even bothered to work out what 100 over 200 is. It's not going to be smaller than something times 10 to the minus 6. So the smallest value is 175 times 10 to the minus 6. It's A. And that was the last question from the Waves homework booklet, question 34.